Hi everyone, I'm Karthik Lalithraj. Today we're going to see how Kinetica and Kinetica UDF feature helps with detecting fraud in credit card transactions. We have a US map which depicts incoming transactions, credit card transactions that are mapped based on the geographic location where your credit card transaction occurs. So this map slices and dices the data based on the transaction category, the transaction type, and does a summation based on the total transaction amounts based on the specific types. Um, One quick look at the data itself. The table is a transaction information, which basically has a number of different properties, but it also has the lat and long, which allows you to paint these credit card transaction location information on a geographical map. What we also have is a concept of a UDF. A UDF is a user-defined function that allows you to execute any algorithm, code, model wrapped up by a Kinetica wrapper and execute it as a compute to grid within Kinetica. So you can create UDFs by simply creating the new button and specifying your procedure, or you could also execute it by simply executing it here and adding the input parameters and output parameters. What we're going to show in today's demo is executing a fraud detection UDF as part of our reveal framework, a reveal dashboard framework. Now, firstly, before you go and perform any analytics, what Kinetica allows you to do is to slice and dice the data various ways. So for example, let's say you want to find out all the people who use their credit card for groceries, right? That's a total of 84.7 million, and that's 6% of the percentage. So you can now click on that, and now you're boiled down to 337,000 records. Let's choose purchase. Within a few milliseconds, you're now down to a fraction of these records. Let's choose a geographical location. Right, so let's say we choose northeastern United States and find out that we have 140,000 transactions within this amount. And let's say we search for a time range and boil this down to a further amount. So as you can see, I'm performing a number of different filters, and every time I perform a filter, it executes in a few milliseconds. So let's say I search for all persons with the last name as Williams, right? So now I was able to boil down my search to around less than 2,000 records. And then if I choose on one of these, you can see that all my search criteria is there, right? So this gentleman's last name is Williams. The transaction type was groceries, and then I had a purchase as opposed to a cash advance, and this person spent $8.40 on this specific transaction. Okay, now finally, what I would like to show you is how you can easily detect fraud, right? So for the purposes of this demo, we have two rules. A fraud is detected when a person makes a transaction over a certain amount. So the spending limit for the purposes of this demo is $500, right? So anywhere from $0 to $500, you are spending. It's not a fraud transaction. Anything greater than $500 is a fraud transaction. So, and then the second rule is if you find a transaction that's not in your home state, then that's defined as a fraud transaction. So just to quickly show you, if we search for transaction amount greater than 1,000 in the entire data set, sorry about that, you can see that we have a total of 10 transactions. So this transaction amount is for healthcare amount for 3428, and for our rule, this is a fraud transaction because it exceeds the given threshold, right? So things like this can be very, very easily detected using UDFs. What we'll do is try and run a UDF which detects all the frauds within the given data set, including amount-based fraud or even outside the state frauds. So for this data set, you will find that the fraud is, let it complete. Okay, there we go. So you can find that the number of fraud transaction is 78, right? So you can apply these fraud rules automatically as and when the data streams in, or you can call an ad hoc UDF that detects fraud. That's it. Thank you for your time.